break it down. Pivot tables, hallelujah. Bar charts, hallelujah. Goal seek, hallelujah. Cause Excel Funk's gonna give it to you. Cause Excel Funk's gonna give it to you. Cause Excel Funk's gonna give it to you. Just stop the lines and stop the clocks. Don't believe me, just watch.
In our last videos, we've been talking about descriptive statistics. We've talked about measures of center, measures of variation, and in this video, we're going to talk about measures of relative standing. Now, there's three calculations that we do for determining measure of relative standing: z-score, percentiles, quartiles. So what I've done is created two fictional farms, 15.5 and 16.5, and said that they have an average daily gain of 0.297 and 0.325. What we want to know is, based on our other data set, our other 32 farms, what is the relative standing? Are these good farms? Are they bad farms? Are they outliers? Okay, and so we do that by doing our calculations. If you look at this chart here, I have those 2 points graphed in the red. You can see the mean in the orange, and these are our other data points. And so we want to get an idea of where the relative standing is. Okay, the first thing that we can do is calculate a z-score. And now the formula for a z-score is x minus the mean over the standard deviation. What is x? Well, x is our new values, or the value we want to know the relative standing of. So I've actually put the formula here. It's called a z-score, and we take the value that we want to know more about, subtract the mean, and divide by the standard deviation. Now, obviously, this calculation is not very tough, and we could do it on paper here, but I'm going to show you how to do it in Excel. So to get our z-score for our first value, we're going to say equals. I'm going to use a parentheses so that it subtracts the mean before it divides by the standard deviation. I'm going to take my x value, which in the first example is 0.297, subtract off my mean. So I'm going to go up here and find my mean, which is right there, close parentheses, divided by my standard deviation, which is right here. And I get negative 1.31. Okay. Now, typically a z-score will range between -2 and 2. What this is telling me is how many standard deviations this is away from the mean. And this particular value is minus 1.31 standard, or 32 standard deviations away from the mean, meaning that it is less than the mean. Well, my mean was 0.311. And it is about 1.3 standard deviations away. Okay. Now, unless my z-score falls outside the range of -2 and 2, my value is a good value, meaning that it's not an outlier in any way. When my values start to become larger than -2, or I shouldn't say larger, smaller than -2 or larger than 2, I have an extreme value or something that I might want to investigate further, and that leads to the discussion of outliers, which we will have at a later date. Let's repeat the process for our second value, 0.325. Again, my formula says this is going to be equal to the value I want to know. I should put a parentheses around that, subtract the mean. So I'm going to go click on the mean, and then divide by the standard deviation. And in this case, I get a value of 1.31. Okay. And if you eyeball this, you can see they do approximately look about the same distance away from the mean, and that's what this is saying. The positive value would mean that it is greater than our mean. Okay. All right, so that's how we check a z-score. Again, any value less than -2, we would say is unusually low. Any value greater than 2, we would say is unusually high. Okay, but as long as it's within that -2 and 2 range, we have pretty much a standard normal value for this data set. All right, percentiles. Percentiles give you a number, so you might be in the 15th or the 78th percentile are the examples I'm giving, but we can pick any number we want between 1 and 99, okay? And what the percentile number tells me is 15, if it's the 15th percentile, 15% of my data will be less than that value, and 85% of the data will be greater than that value. So when I calculate a percentile, it returns a value that should fit into my data set, and 15% of that data will be less, 85% will be greater. Or, for example, if I was looking for the 78th percentile, 78% of the data is less, 12% of the data would be greater. Right? For example, if you go into the doctor's office and your child is in the 15th percentile in weight, that means that only approximately 15% of children at their age weigh less, but 85% of children at that age weigh more, and that might be a cause for some concern or something that you might want to watch going forward. Or if your child brings home tests that says they're in the 78th percentile, you can celebrate, because that means that 78% of the children did poorer on the test, while only 12% did better. So your child is a superstar. So that's how we present percentiles. And again, remember, we can use any number here. I've just used 15 and 78 as examples. Let's calculate the percentiles for our two examples. So we're going to say equals, and now our keyword is percentile, and we just want to use the word percentile, open parentheses. And now it says array, so we're going to highlight our array here, okay, and then the percentile. So we're going to put in it as a decimal 0.15. Okay, so the 15th percentile of this data would be 0.2986. All right, if we're wanting to know our relative standing, we can see that we're approximately near the 15th percentile. And we could find this for, say, the 14th, the 13th, until we actually got that value. If we wanted to know the 78th percentile, we would say equals percentile, open parentheses, highlight your data, comma, 0.78. Again, it's the 78th percentile, but notice that I'm putting in the decimal, 0.78. It's a percent, right? So it says 0.301. Well, the good news is here, this particular farm did better than the 78th percentile. So this farm right here is doing a really good job. This farm right here did worse than the 15th percentile. So this farm's lacking a little bit. Okay, so the percentile is just a value. It's going to be a value that fits into your data set that tells you what separates the bottom, whatever percentile's in here, from the top, and you subtract that from 100. Okay. Now, it's more useful probably to just go ahead and calculate the quartiles. So what are quartiles? Quartiles are special percentiles, okay, meaning that they are percentiles, but they have fixed values. Sometimes you see quartile 0. I'm not sure our book talks about that one, but you can actually calculate it in Excel, and that's just going to be your minimum value. In other words, 0% of the data is below that, and that's your minimum value. All right. The second, well, we call it quartile 1, is the 25th percentile. Okay. So notice here, I always think about this as having quarters. If I have a quarter, I have a 25 cent, 2 quarters, 50, 3 quarters, 75, 4 quarters, 100%. So quarter 1 is the 25th percentile. It's the value that separates the bottom 25% from the top 75. Quartile 2 is the 50th percentile. It separates the bottom half from the top half, but this is also our median value, right? Remember, if we put our data in order and find the middle value, half the values will be less than them, half the values will be greater. And so the 50th percentile is actually the same thing as our median value. Quartile 3 is the 75th percentile, meaning that 75% of our data will be below that value, 25% will be above. And then quartile 4 is just our maximum value, 100% of the data. Okay, so we can find the quartiles for our data. All right, and again, our built-in function here is going to be equals quartile, open parentheses. You're going to highlight your data, make sure you get them all, and then comma, and now I'm going to put in a 0 to find the minimum value, and it's 0.2958. Well, notice up here, 0.2958, that was our minimum value. So again, more than one way to find something. Quartile, highlight your data, comma 1, close parentheses, 0.304. That would be my 25th percentile, equals quartile, highlight your data, comma 2. All right, and like I said before, that's going to result in our median value. Again, notice here, median value, it matches up. Quartile 3 is our 75th percentile. So it's going to be really close to our 78th percentile number. Okay, 0.31. And then finally, our last one is going to be our maximum value. Highlight our data, comma 4. And this should be our maximum value, 0.3324. 0.3324. Okay, so again, quartiles are just fancy percentiles. And now I can look here, all right, the reason for calculating the quartiles is 0.297 is somewhere between 0 and 25. 0.325 is somewhere between 75th and 100. So these guys were doing in the top 25%. These guys were doing in the bottom 25%. Okay, so again, that's how we look at our relative standing. And finally, I'm just going to type in our formulas over here. So to do a percentile is equal percentile, open parentheses, you put in your data, and then you put in the decimal of the percentile. Okay, so for example, we did percentile. It was B2 to B33, and then we put in 0.15. Okay, and to do our quartiles, it's equal quartile. Put in your data, and then put in the quartile number, 0 to 4. Okay, so for example, we did equals quartile. B2, B33, that was our data range, and then we put in the number 3, and that gave us this one right here. Okay, so I hope this helps. If you need more help, please let me know.
Excel Funk's gonna give it to you.